Here we are given 2 points and asked to find a formula for an exponential function that passes through the given points. So the points are 2, 5, and 4, 1. Neither of these points is our y-intercept or vertical intercept, so we don't have a given initial value, and we're going to need to solve for both a and b. So when we're writing an exponential function, we're trying to write a function in the form f of x equals a times b to the power of x. So we need to find a value for a and for b. So since we don't know either of those values, what I'm going to do is I'm going to start by plugging in each of my points into this function. So I'm going to think about my input and my output. So for 2, 5, we could also think of this as f of 2 is equal to 5. So plugging in 2 for x, we would have a times b to the second power will be equal to 5. For our second point, 4, 1, so f of 4 is equal to 1. This means a times b to the fourth power is equal to 1. So we now have two equations that each have two variables. So we're now going to make a substitution. So I'm going to take my first equation and solve for a. So dividing both sides by b squared, we have that a is equal to 5 over b squared. So a substitution is when we take one equation and plug it into another. So since a is equal to 5 over b squared, I'm going to take 5 over b squared and plug it into my second equation in place of a, what it's equal to. So this gives us a new equation, 5 over b squared times b to the fourth is equal to 1. So notice after making that substitution, our equation now has just one variable instead of two. It just has the variable b. We can do some simplifying since we have a b squared on the bottom and a b to the fourth up on top. This b squared on the bottom can cancel two of the b's from the b to the fourth and leave a b squared. So we have 5b squared is equal to 1, and keep going to solve for b. So I'm going to divide both sides by 5. So b squared is equal to 1/5. Since it's a b squared and we want to know just b, I'm going to take the square root of both sides. So b is equal to the square root of 1/5. Normally when we use our square root property, we make a point to remember to do the plus or minus. Our base b in an exponential function must be a positive number. So of the plus or minus, we're going to choose just the plus in this case. In our actual function, it's often helpful to also give a decimal approximation when we have a radical like this. So if we put the square root of 1/5 into our calculator, we see that it's approximately 0.4472. So that tells us one of the values that we're going to need for our function. We still need to find our value for a. So to find a, we can go back to what we knew originally about a. We said a was equal to 5 over b squared. So now that we know b, we can plug in to find a. So for finding a, I'm going to go ahead and use the exact value of b, the square root of 1/5 squared, since it's 5 over b squared, because when I square a square root, those cancel each other out and leave just the 1/5. 5 divided by 1/5 is the same as 5 times 5 over 1, or 25. So putting our a and our b together, our exponential function that will go through those 2 points is going to be 25 for our a times 0.4472 to the power of x. So this is an exponential function that will pass through the points 2, 5, and 4, 1. I'd encourage you to graph this function on your graphing calculator or on Desmos and check to see that the points 2, 5, and 4, 1 really are on the graph.